Hey everyone, in this video I'm going to talk about some workflows you can use to generate assets for games using AI. I'm going to look at how to use models that are freely available to generate sprites and maps and also dialogue. So just using models that are freely available on these multi-model platforms like OpenRouter and Replicate. And I'm going to show you how I am currently using these to work on a game that we're developing. This is an educational game to help people learn how to program, actually. So I'll show you a quick demo of it first, and then I'll show you sort of how we're using different AI models to build different parts of the game. So this is kind of the hub for building the game. This is like a UI built to help me generate assets and wire everything together. So we can come in here to create scenes, create maps and make them walkable and things like that. And then we can come in here to make different characters. And then we connect different things through this world view. So like map transitions and things like that. So I can show you a really quick demo of the game mechanic here. It's mostly based on dialogue to progress the story, but the point is actually to learn how to program. So you can come up to a character and speak to them. The basic plot for this game is there's like an AI mega corporation trying to take over the world, and you're trying to join these hackers. And so you have to learn how to hack. And the sort of main game mechanic is this terminal system here. So you can log into these computer terminals, and they're actual Linux terminals that work with bash commands. Make this a bit bigger. So you can read files and things like that. And so the story will be a combination of like character dialogue and then learning the skills to operate on these computer terminals. Won't go into the this Linux stuff right now, but if we come back to this build hub, I'll just talk a little bit about the different assets that we're creating with AI and then how we're putting it all together. So for characters, and I'll say this is pretty rough at this point. We're not really looking to release a AAA studio quality game. The point is just to make the learning experience more interactive. So the assets are a bit rough at the moment, and we're still working on like different pipelines, but this is just kind of where we're at. We're going to keep improving it, but figured I'd share some of these things in case you're interested in doing similar stuff. So let's start a character from scratch. Let's say cyberpunk vendor or something. So close this here. As you may have realized, the sort of theme of this game, the aesthetic is cyberpunk, which I think is it's a fitting sort of aesthetic for learning how to work on the terminal, which is the first part of this game. So we'll type in this here, and the first thing we see is actually a text prompt. So one thing to keep in mind when you're generating assets is raw prompts often don't work that well. So if you take a prompt like what I just typed in, cyberpunk street vendor, and feed that to an image generation model, sometimes that works. But if you need specific things like we do here, which we'll see in a minute, it's often a good idea to have an intermediate step where you have your user prompt or your sort of raw prompt, and then you have a transform prompt to change it some way to like something like this. You feed those to an LLM first, and then you get a sort of pre-formatted prompt back. So this is a good place to talk about OpenRouter. OpenRouter and Replicate are the two places that I'm going to explore for models. So OpenRouter is really great for LLMs. It has all the major large language models like GPT-5, Sonnet, Gemini, and a ton more. If you go to openrouter.ai, then you can see all the models that they have. I don't know how many hundreds it is at this point, but it's a lot. And it's great because if one provider goes down, you can fall back to others. If you have a user-facing application, you can optimize based on how much reasoning it will do or how much latency, how expensive it is. So depending on what's important to you for your app, you can sort of mix and match different models. So this is a really great tool, a really great place to know about if you don't. And the other one is Replicate. I'll come back to this in a second, but that's more for images, videos, audio, that kind of thing. So basically what we do here is we put in the prompt, we feed it to OpenRouter, and we get this back, and then we feed this modified prompt onto Replicate, and we generate a bunch of images. So the point here is we want like a reference sprite. This is obviously a 2D sort of top-down game. We want like these reference sprites that we can then generate poses from. So say we pick this one here and continue with selected. Then what we're going to do, we have our sort of raw image, is we're going to generate different poses. So a right-facing pose, a down-facing, a left-facing, and an up-facing. I've seen some of the systems that are out there that are using 8 directional poses. You can do that too. There's no reason you couldn't. But I'll just kind of explain how we're doing these 4 poses, and you can extend the logic to 8 if you're going to do that. So what we do, we also generate a portrait photo. So these come out pretty rough sometimes, and we just regenerate them. So this is supposed to be the down walking animation. So here's our reference sprite. This is supposed to be them walking, the character walking down towards the screen. So if we click regenerate, it'll generate it again and hopefully be better. So we'll see what we get back. So this is a lot better, right? This is sort of a base for this walking cycle. But before I go on, what we do is we feed this sprite here with some text about how to transform it, which we can see here. So high angle top-down view, character facing the camera, yada, yada, yada. And we're doing this not using text to image, but using image to image. So if we come over to replicate, so this is the replicate homepage. If you go to replicate.com, you come to explore, you can pick different categories of models. We'll come into image. The ones that we're using for this transformation, I think is called context-dev. And so this comes from Black Forest Labs, which is the provider. And then this is the name of the model. So you'll see this sort of style of like model identifier on both replicate and OpenRouter, where you have like, here's Black Forest Labs again, incidentally, but you have the name of the provider and then slash, and then the name of the model. So if we come back to this, the basic idea is you feed some image and you feed a prompt, and then you get a modified image out. And so over in our case here, we're feeding this base sprite, and then this here saying that we want the character facing the camera. If we come over here, back view, character facing away from camera. And the idea is you want to play with these different prompts until you get reliably what it is you're looking for. Like here, we can flip this around. This is half decent. This one's not very good, so we'll regenerate it. With these generative AI pipelines, you often have to generate assets several times before you get what you want. And so this is part of the reason to build a UI like this. Just as a sort of higher level meta point, I find it really helpful to build GUIs or like interfaces to help us with our workflow. So this game is using Phaser.js, which is a JavaScript game creation framework or library. And so it does things like collision detection and rendering walk cycles and things. But this here is kind of like it's like our game engine add-on in a way. It's like, it's just a way to manage all the different pieces that we're generating, but it's not actually the game engine. We are looking at using some engines like Godot or Unity or whatever, and integrate it with that. Like I know a lot of these engines have MCP integrations with different tools and so forth, but right now we're just keeping it simple. We'll see where this goes. But anyway, the point is having tools to help you regenerate assets. People complain about this a lot. If you're using a paid service, this, by the way, will be free. I'll just put it on GitHub. You can download it and play with it if you want to use your own API keys from OpenRouter and replicate. But if you buy 1,000 credits or something and you have to generate a character 15 times to get what you want, it's pretty frustrating. But it's kind of the nature of the beast right now. Like generative AI still isn't perfect, even though it's amazing compared to where it was a couple of years ago. So anyway, that's a bit of a ramble. But the point is, we've regenerated these sprites to where we're sort of happy with them. So the next thing we do, there's a few different things you can do here. I've seen some platforms are using like skeleton walking animations. So they'll take animated rigs and do like pose estimation. So you get like a ball and stick diagram of the character. And then you use the same image modification tool to like take that skeleton plus the character sprite and paint each image like that. That works so sometimes. What we're currently playing with is generating videos. So I'll start these. And I should have used actually this other model. So we're generating videos and then extracting the frames, removing the background, and then turning those frames into a walk cycle. So I've been playing with 2 different image to video models from Replicate. One is Seed Dance 1 Lite, and one is WAN 2.5 from Alibaba. So if you come over here, they type Seed Dance, you'll get this, or this is Pro. So Pro is better than Lite, as you might imagine. And it's nice to have this little, playground thing here so you can play with stuff before you integrate it into your app. But it'll show you the pricing down here. This is Seed Dance 1 Pro. I think we're using 1.1 Lite. but it doesn't really matter. Another really nice thing about having a platform like this, like OpenRouter or Replicate, rather than using the model platforms directly, like OpenAI or Claude or whatever, is that you can swap out models really, really easily because they all have a standardized interface. There's some difference depending on the models, but for the most part, it's sort of, you can have a drop down in your builder here where you just have 2 or 10 different models and you can experiment really easily. So if we look for Juan here, we'll see, this one, for example, is what we're using. And you come over to API, this will give you a reference for how to integrate it. So whether you're using a Python backend or a Node.js, or you're using some other way to call the backend, and this will give you basically a quick start, how to set it up quickly. And if you're using AI to generate your code, which I presume you are, you just basically paste this into your context window, if you're using Claude Code or Cursor or whatever. What I really recommend doing, though, is the following. So this terminal here is in the directory of this game, and we have this directory called external API docs. And in here, I have documentation for the 2 different platforms. And specifically, like Replicate, for example, for each model that we're using, what I do is I grab the model documentation and stick it in here, and then I tell the agent to look at it. And Replicate makes this super easy with this copy button. If you click copy, it'll copy this here to your clipboard. So basic model info, the model inputs, the output schema. So this is like perfect. It's formatted for AI so that you can just plug this file into your context, and it makes it super fast to put a new model in there. One of the best features. So that's how we're doing video generation. So if we click check status, we're just polling here for the video. Then you can see the video here, and this looks half decent actually. This one, not so good. And let's see this one. This one looks okay. And this one looks so-so. Not amazing, but it's usable. So what I would do here is change to this other model, and I would regenerate this video and then proceed. So after we have a video, the next step is we convert it to frames. So we're using this library called Sharp.js. So this is just running on our Node server, which is just running locally on our computer. If you want to pull this repo from GitHub, it'll install this in your directory. So basically, we use this to pull all the frames out of this animation. So when we click extract frames, then down here we now see the walk cycle. Now this is a bit janky. It doesn't look great from the outset. So we have tools here to help us clean up the animation. So here we have different animation counts. Or frame counts for the animation. We can have 8 frames per second, 40 frames per second, whatever. I'll just stick it at 8 for the moment. And then you see, you may be able to see this. There's a lot of artifacts here in the background. So it might be a little bit to see on your monitor, but a little difficult to see. But there's some sort of background issue where the first thing we do is we generate the sprites on a white background, which I recommend doing. At least for this workflow, it works pretty well. You can see here we have a white background and a black outline, and this is in our prompt. So we say, at least in our original prompt, we have it. I guess it didn't make it through here, but it makes it easier to remove the background if you do this. So the first thing we do is just we basically use code, like deterministic code, not an AI, to alpha the white. So you can check the code if you want to see how this is done, but the white becomes transparent, but there's still sometimes images aren't perfectly white with the background. There's some glitching here. So the second thing we do is we use AI to remove the background, and this tends to work quite a bit better. We'll come back in a second. For this, we're using on Replicate RemBG. There's a few different models that do background removal. So there's RemBG Enhance, RemBG, RemBG Video. There's I think there's some just called Remove Background. Yeah. So you can look around on here for different ones. The one we're using is works pretty well for us. It's got like 5 million views, 9 million runs. So yeah, you can see feed it an image and it takes out the background. So if we come back here, you can see, again, it might be a bit hard to see, but the background is much, much less It's much better. There's no flickering or jankiness in the transparency of the background. So this is much more usable. So basically we do that for all 4 directions, and then we click this finalize button and it just puts the animations in a package basically for our game. So that's character generation in a nutshell. Again, there are different ways you can do this, of course, without videos, using rigged animated characters in 3D and stuff. We explored that a little bit, and we're actually working on some 3D stuff here, which I'll talk about in a little bit. But there's lots of different things you can play with here. Like for example, we sometimes have shadows in our characters at the moment. Like this one, you can see there's a shadow under his feet. So like you might want to use segmentation, which I'll talk about in a minute, to like find this shadow and then inpaint it out. So there's like different things you can do to add on. This is just a basic, quick and dirty, well, relatively quick way to get some sprites put on a world. So the next thing I'll talk about is scene generation, which is a different set of tools. So here we have, the first thing we do is just generate an image, not surprisingly. And again, if you expect to get exactly the look you want, the style and the layout and everything from the first attempt, you're probably going to be disappointed. You really have to play with your prompts. You can try, 5, 10 different models. Sometimes you want to generate 4 or 5 different images at a time and take the one you like best, like we were doing with characters. Just try a sort of volume approach. One thing I would recommend is there's Flux, I think it's Flux Dev. This model works really well, and it's really cheap compared to a lot of the other models. So this is 2.5 cents per output image, whereas something like Nano Banana, which is also on here, is 15 or 30 cents per generation. So it's 7 times cheaper. So looking around, depending on what you're doing, right? If you're trying to generate final user-facing assets, you probably might want to spend a bit more to generate higher quality assets. But if you're testing a pipeline, you're doing internal stuff, whatever, like you might want to check and see which one is cheaper and use that. So we generate our image. From here, we don't obviously want to give a user just a flat image to walk over. That doesn't work very well. It's a bad experience. So the way we solve this is using a walkability mask. So this mask overlay, green is walkable and red is not walkable. And there's a couple parts to this. Number one, let's say we generate, do Cyberpunk Cafe. We'll generate a new map just to give you a sense of like how this works. So we first just generate the image. Here it is. So we could put a character on here and walk around. But we're probably going to be walking on top of this stuff here. So if we show the mask overlay, it's actually sort of backwards. There's a bunch of stuff up here that shouldn't be green. And this is because of how we're setting it up by default. So let me explain this a little bit. So what we do basically is we feed this image. If I hide this so you can see it a bit better, we feed this image to a segmentation model also on Replicate. So we use something called SAM, segment anything. And so here's one provider plus model. I think this is the one that we're using. But there's often different providers for the same model, and you just look around and see which one works better. So here, the way this works is you feed it an image and you feed it some text prompt, which here is text and watermark. And so the model will take the image and it will try to find whatever your prompt is in the model, and it'll return what's called a mask. And a mask is basically the part of the image that you don't want to exist anymore. And then you can take that mask and that image and then feed it to an inpainting model. So another basically image to image model. And you could say whatever, you could remove this, you could remove the watermark, you could change it to something else. In our case, the first thing we're doing is we're generating a segmentation mask of floor tiles. So in an interior world, like in an inside somewhere, we just want floor. So if we change this to floor, what it was before is walkable areas, floor, and ground. So it's sort of a generic thing. But if we put it into just floor and we show the mask overlay, we'll see we'll get a new, we're just calling that replicate endpoint, and we can see it's a lot better. So now we just have this floor segmented. It's not perfect. You'll have to probably touch up sometimes, like maybe these little red spots, or if you want to be able to walk underneath something, sometimes you need to do some adjustments. So we've added like a tool here so that we can adjust the map, like where it's walkable by painting over it. And this is another example of what I was talking about, where I was saying building tools so that we're interacting visually with our assets rather than through code really helps a lot. So anyway, this is now basically ready to go. So I could put a player here and I could say test in game, and it should load up the map and I should be able to walk around. And here we are in our new fancy new cyberpunk cafe, which is great. You know, this is really fun. Again, it's not perfect. There's some jankiness with the shadow. If I hold shift, I go super fast. That's what that was. But you can see his shadow pops in and out sometimes for the left animation. But, you know, for the most part, we have a walkable scene here. We can place other sprites like you saw before in here and then interact with them. I'll talk about generative dialogue in just a second. That's what this is here. The last thing I want to talk about is inpainting in terms of scenes. So if you generate these maps and you want to be able to modify them, but you don't want to hand paint things, some people, of course, do want to hand paint things, but let's say you want to just use AI for everything. I'll select this brush tool and I'll select this region here. So we'll use this as a mask to send to an inpainting model. And so again, this is a reason to build these tools for yourself so that you can do this visually rather than through code or something. But if we type in here floor tiles and apply inpainting, what should happen is we send this mask plus image over to the model and we get back a response that doesn't have a table there if it works properly. Let's see what happens. Okay, I accidentally restarted the server, and so I've generated a new map here and used inpainting on this object here, this table, to get rid of it. So the prompt I used was something like empty floor, no obstructions. So if we go back here, we can try it again real quick. We have a brush mode here, so let's try that again. We'll just use the same prompt. So I think the prompt I used was empty floor, no obstructions. So let's test this. While it's generating, I think I misspoke earlier. The model we're currently using is this one here, the Flux Fill Pro. It's 5 cents per inpainting, so it's not free, but you know, if you can get a map for 25 cents or something, that's a lot cheaper than what it used to cost. So there you can see the image is gone. We undo it, it comes back. But you can use this to modify things. You can't, not just for getting rid of things, but I'll just show you one more example because I think this is one of the most useful things that we've got to play with. So I'll change this like vending machine or whatever to like a computer terminal. And there you can see what was a vending machine is now a cool looking computer terminal. And so I use this for setting these computer terminals in the game, this mechanic I talked about before. Doug's terminal. Doug's one of the characters in the game. We could place it and then we could, you know, set our player spawn and then go play with it. So that's the basic sort of image generation stuff that I wanted to cover for those mechanics. The next thing I'll talk about is, or the last thing I'll talk about is using dialogue generation. So dialogue generation is kind of an easy win for using AI in your games because it's sort of the use case that most of us are familiar with in terms of generative AI from ChatGPT and Gemini and so forth, at least in the general public. Maybe not true in this crowd, but in any case, the way that I'm implementing that is through using OpenRouter for the model selection. And so we have a few models for different tasks in here, like prompt transformation. Depending on the task, sometimes different models are better for your task. So in here, we have a settings thing where we configure different prompts and defaults, like the default character sprite and so forth. Down here is for the dialogue model. So these are models here that are all on OpenRouter. So there's Nemotron is a really, really fast one, and it's quite cheap. There's Google Gemma, which is relatively cheap, and well, it's very cheap and very fast. There's Grok, there's Claude, and you can add whatever you want, right? So like I said before, you can come to here and type whatever provider you want and just basically grab the name of the model and plug that into your API, and it will add that to your stack. So one thing to note is you really want snappy, fast dialogue when you're, you know, if you're going to integrate LLM dialogue into your game, you're going to want it to be quick, of course. There's a trade-off between how much reasoning it does. You may have seen these reasoning models that spit out the reasoning tokens. That can really slow down your interface if you're waiting for the model to like think through its response. You don't always want that. So one option is to choose models that don't do reasoning. And another option is to figure out how to turn that reasoning off. So in OpenRouter, I'll just show you an example of what I mean actually before I show you this. So let's say we play this world here. So if we come and talk to this character here, Vex, and we say hi, then we get a response pretty quickly streaming in. He's not talking to me right now. But if, actually, if I reset this, delete our message history with him, just so we have a longer message, you can see there's an almost instant response from the character. If I change this to a model where we're reasoning first, so like let's say we pick the reasoning to, we set it to Opus 4.5, which is the newest model from Anthropic, and reasoning effort to high. This is covered in the reasoning docs, which I'll bring up in a second. And if we go now talk to our NPC, we can see there's quite a long delay between when we type anything and when we see a response back. It's not a very good user experience. We're getting tokens back here, the reasoning tokens. So if we come over and talk to him again, we'll see streaming tokens over here. But we don't see any dialogue tokens because the first chunk of them are just reasoning tokens, which we don't actually want to see in dialogue. So I'm kind of belaboring this, but the point is, if you're building a dialogue system, reasoning is probably not something you want to use. You probably want to turn that off or set it to low, perhaps. But this still adds quite a bit of latency, I find. So you can use faster models. You can turn reasoning to low or off. And then another trick to learn is when you're setting your system prompt, which is sort of how you set up your user personality. So for example, in this scene here, we have this character. This system prompt is basically what tells the AI how to act, right? So it tells the AI its name and sort of its characteristics and how it should respond and some examples of what to do and so on and so forth. In the system prompt, for some models like Nematron, I'm not sure how widespread this is. I had to sort of dig for it. If you type / and then no_think, this will make it not reason. So I think Nematron doesn't support the reasoning effort parameter, and by default it has reasoning. But if you include this, it bypasses it, and it's super, super fast. So I'll show you. Well, actually, I don't need to demonstrate it, but just remember this if you're trying to build a fast response. And the last thing about this is if you come over to, this is the documentation on OpenRouter for the responses API subsection reasoning. This will tell you how to set this reasoning, this effort parameter, how long it'll spend, how many tokens it'll spend on reasoning. And if you want it to go quick, just set effort to none. I think if you leave this off, it can turn it off as well. But I think some models default to using it, like Nematron, and other models default to not using it. So you can be explicit here. And I think it's the case that some models don't support this parameter, but I could be wrong. And so that's it. That's my quick walkthrough of how to use OpenRouter and Replicate to generate images and character sprites and maps and dialogue and so forth. And so hopefully this was helpful if you're trying to get into AI-driven game development. And if you have any questions, please leave them below. Thanks.